In this video, we're going to learn about phase and phase difference. Okay, I've got two mass spring systems. They're not horizontal like we've been looking at. These are vertical mass spring systems, but that's okay. We'll just pretend they're horizontal. I'm going to pull this one down, displace it, and let it go. And it oscillates with simple harmonic motion. And this is an identical mass spring system. Same exact mass, same spring constant K. So I pull this down and I let go. And the oscillation will be exactly identical. Exactly identical, right? Well, no, not exactly. Because these two objects are not at the same stage of oscillation. Let me pause. When this one is up, this one is down. And if we go slowly, when this one gets to the bottom, this one's at the top. So they're moving in opposite directions. The oscillations are the same, but they're not at the same part of the cycle. What we say is that the two systems are out of phase. So what is phase exactly? Phase just refers to where a system is in the oscillating cycle. For example, this system is at the bottom of the cycle, and this system is at the top edge of the cycle. They're at different phases. So what's the difference, though, between the two phases? It's easy in this case. It's half a cycle. That's how far off they are from each other. Let's take a more complicated situation. And the way we analyze more complicated situations is with displacement time graphs. So here are two springs oscillating. They're two different springs, and they have the exact same oscillations, same frequency, same period. The only difference is that this one starts at a different part of the cycle from this one. So how do we find the phase difference here? Because it's not half a cycle, it's a little bit harder to figure out. Here is your process. Find a distinct peak. I'll use the first peak or crest and mark where that is, and then find the same crest on the bottom. So here's the first crest, and you mark where that is, and the phase difference is the amount separating those two. And we use the Greek letter phi or phi for the phase difference. Phi, phi, pho, phum. I wish I had looked up what the correct pronunciation is before making this video. Oh well. So this is the phase difference, how much of a cycle separates those two. But look at our x-axis. You might look at this and say, well, the phase difference should be measured in seconds, because the amount between these lines is going to be some number of seconds. But in fact, phase difference is different. It's how much of a cycle separates the two graphs. Is it half a cycle? Is it a quarter cycle? So look at this graph over on the left. Here's one full cycle. Add my grid lines, and here's the full cycle. Now, we want to know this little sliver from here to here, what fraction is this of the full cycle? And whatever fraction that is, that's the phase difference, right? Okay, so let's figure this out. First, let's figure out how many seconds separate these two lines. That'll help. So this first peak on the top graph is at 3 seconds. The first peak on the bottom graph is at 5 seconds. So the amount of time separating them is 2. Is that my phase difference? No, that's not quite it. I have to take that 2 seconds, and I have to turn it into a fraction of one complete cycle. So I can divide it by, how can I turn this into a fraction of one complete cycle? Well, I know how long it takes to complete one exact cycle. The period. We start at 0, and we go up and down, and when we end, this is at about 12.5 seconds. So I divide this sliver by one cycle, specifically the time for one cycle. And now I've taken this little sliver and I've turned it into a fraction of one full cycle. But we don't stop there. Instead of saying the phase difference is half a cycle or a quarter cycle, we convert it to radians. So if your phase difference is half a cycle, one full cycle is 2 pi radians, and you would have 1 radian. So we take this fraction and we convert it to radians by multiplying by 2 pi radians. Here's why this works. If the phase difference were half a cycle, this would be 0.5, and half of 2 pi is pi radians. So you take your fraction, you multiply it by 2 pi as a way to reduce the 2 pi radians into whatever fraction we have here. When you calculate this out for the example here, you get about 1.0 radians. So what's the equation exactly for phase difference? Well, we start with our symbol here, Greek letter, and we take a fraction, we multiply it by 2 pi. In the numerator, we took the difference in time between the two peaks. And the denominator was the period. And this is a fraction of one cycle. It's how much of one cycle separates the two. And then we take that fraction, that percentage, and we convert it to we convert it into radians by multiplying by 2 pi.